Welcome to the video lecture series of Grade 10 Physics. Today we will discuss about electricity and the topic is factors affecting resistance of a conductor. So what are the factors that affect the resistance of a conductor? Consider a copper wire of length 2 centimeter. Okay, and if electricity is passing through this conductor and if the value is measured, for example, if I is 4A, I means the current passing through the conductor and the value is 4A. And you are considering another conductor of length 4 centimeter. It's of a same material and the current passing is 2 ampere. So when you compare the length of the two substances, the first one is 2 centimeter and the second one is 4 centimeter. But look at the ammeter reading. The current passing through the first conductor is 4 ampere and that of second one is 2 ampere. Which means if the length of the wire is increased, okay, when you increase the length of the conductor, the current will be decreasing. So what is the reason for this? When you increase the length of the conductor, the resistance will more, which means a higher length will give you a higher resistance. So if the resistance is very high, the current will be less. So what is the relation between the resistance and length of the conductor? When the resistance increases, length also increasing, which means length is increasing, resistance also increasing. Both are having a direct relationship. Now, look at the second example. Length is of 2 centimeter. So the current reading we are taking it as 4 centimeter. But we are considering the same conductor, copper wire, but the area of cross section, the area will be considering is more than the first one. Area we have increased over here. So which means the length will be same but the area is increased, area is doubled. So that ammeter reading shows that the current passing through the conductor is 8 centimeter. So when you increase the area of cross section, the current will be more. If the current is more, which means that it will have a low resistance. So what is the relation between resistance and area of cross section? If area of cross section is doubled or increased, resistance will be low. So R is actually inversely proportional to area of cross section. So we are writing 1 by A. If you are comparing these two relationships, you will get R is proportional to L, which means resistance is directly proportional to the length of the conductor, but it is inversely proportional to the area of cross section. So R is proportional to L by A. Now we can remove the proportionality constant by putting a constant called electrical resistivity, that is rho. So R equals rho into L by A. This rho, the proportionality constant, is called the electrical resistivity of the material. Rho is the electrical resistivity. We can simply call it as resistivity of the material of the conductor. In the previous case, we have considered copper wire. So in that case, rho is we are considering according to the copper material. If we are changing and into another material, maybe it is nickel wire or aluminum wire, all these factors which we discussed will be different, because resistivity and resistance actually both are depending on the material. It is actually depends on the conductor, nature of the conductor. So rho is the electrical resistivity, or simply we call it as resistivity of the material of the conductor. So this is a common relationship which we are using to find the resistance if length and area of cross section is given. From this equation we can derive rho also. Rho is equal to, when you cross multiply R and A, you will get rho. So rho is equal to R into A divided by L. Fine. So what is electrical resistivity? Electrical resistivity, or simply resistivity, it is a measure of the resisting power of a specific material. So resistivity will be changing if you are taking different conductor. So copper resistivity will be one thing, and if you are taking aluminum material, aluminum resistance will be all of different type, which means it will be depending on the material of the conductor. Now, what is the SI unit of resistivity? That is ohm meter. Resistance, it was the unit is ohm. Here it is ohm meter. And actually, as we told before, it's a characteristic property of the material. It will be depending on the nature of the material. Usually metals and alloys will have very low resistivity. That's why they are considering as good conductors of electricity. And their resistivity is given in the order 10 raised to minus 8, which means 0, 0, if you are putting 7 zeros, 6, 7, 8. So the resistivity is very, very low. So usually metals and alloys will have very low resistivity. That's why they are acting as good conductors of electricity. By the time insulators and rubbers, if you are considering insulators like rubber, rubber and glass, they will have very high resistivity, which means their resistance power is very high. That's why they are not conducting electricity. So substances which will have low resistivity are considering as good conductors of electricity, and the substances like very high resistivity are considering as insulators or bad conductors of electricity. Both the resistance and resistivity vary with the temperature. So basically there are four factors affect the resistance of a conductor, and for deriving the formula we have considered only two factors. The first one is length of the conductor and the cross-sectional area of the conductor. And when resistance increases, length of the conductor also increases, which means length increases, resistance increases. And if the area of cross section is increasing, resistance will be low. It will have an inverse relation. One is increasing, the other one is decreasing. And the third factor is material. Resistance and resistivity both will depend on the nature of the material and also the temperature of the conducting substances. Now, there are few NCRT questions based on this topic will be asking continuously. The first question is, alloys are commonly used in electrical heating devices rather than pure metal. So the electrical heating devices, you already know, electric iron, toasters, etc. So in these cases, we will not use the pure metal. We are using alloys. Alloys, it's a combination of metal and non-metal. So the reason is alloys do not oxidize. Oxidize means burn readily at high temperatures. So because in electric heating devices, very high current is using. So by the time the temperature inside the material will be increased, if you are using a pure metal, it will burn and that will damage the device. That's why we are using alloys rather than pure metal. And also the resistivity of an alloy is generally higher. So resistivity is high, you already know. They will be poor conductors of electricity. Now, the second question, tungsten is the most used element for filaments of electric bulb. What is the reason behind this? As you know, tungsten is having very high melting point. Okay, so its resistivity will be very high. So it does not burn easily at high temperature. That's why tungsten is used as bulb filaments. And the third question is a very common question. Copper and aluminum are generally used for electrical transmission lines. Why? Because they are good conductors of electricity. They have very low resistivity. Okay. So that's why they are used for electricity transmission. Now we can solve some numericals. The first one is resistance of a metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. So the resistance is given. A resistance of a metal wire of length is 26 ohm. So R is equal to 26 ohm. If the diameter of the wire is 0.3 mm, what will be the resistivity of the metal? So diameter is given, D is equal to 0.3 mm. What will be the resistivity of the metal at that temperature? So you need to calculate resistivity rho. Okay. So resistivity equation we already know. Resistivity is equal to R into A by L. Okay. So A is not given. R is given and L is also given. What is L? Length of the conductor is L is equal to 1 meter. So these are the things given in the question. Length is given, R is given, area of cross section is not given, but by the time they have given D, diameter is given. But it is given in terms of millimeter. So how do we convert into meter? 0.3 into 10 to the power of minus 3 meter. So this is diameter. So R is equal, you need to calculate radius from diameter. Radius is equal to diameter by 2. So R by D by 2. So 0.3 divided by 2 into 10 to the power of minus 3 you can take. So it will be 0.15 into 10 to the power of minus 3 meter. Now you can calculate area of cross section. A is equal to pi r square. Okay. Now substitute the values. Pi you can take it as 22 by 7 or 3.14. Anything is fine. 22 by 7 into r square. R square means R is 0.15 into 10 to the power of minus 3. So 0.15 into 0.15. 10 raised to minus 3. If you double, you will get 10 to the power of minus 6. Okay. So this is area of cross section. Then you can substitute this value directly into the resistivity. No need to simplify here itself. So resistivity rho is equal to resistivity rho equals R into A by L. R is given 26 ohm. And area of cross section is 22 by 7 into 0.15 into 0.15. That you will get 15 into 15 is 225. But this is 0.15. So 15 into 15 you will get 225. And the decimal point, if you correct, it will be 0.0225. 0.225 into 10 to the power of minus 6. Now, what is L? L is 1 meter. So length you can into 1 meter. So overall it will becomes 26 into 22 by 7 into 0.0225 into 10 to the power of minus 6 divided by L. Okay, so when you solve this equation, you will get 1.8385 into 10 to the power of minus 6. And its unit is ohm meter. Now, the second numerical, what will be the resistance of a metal? Resistance, you need to calculate the resistance R of a metal wire of length 2 meter. So length is given 2 meter and area of cross section 1.25 into 10 to the power of minus 6 meter square. So area is given. Area is equal to 1.25 into 10 to the power of minus 6 meter square. If the resistivity of the metal is 1.6 into 10 to the power of minus 8 ohm meter. So resistivity rho is equal to 1.6 into 10 to the power of minus 8 ohm meter. Either you can write the symbol of ohm or you can write in words ohm meter. So resistance is equal to, we have the expression resistivity into L by A. Now resistivity is 1.6 into 10 to the power of minus 8. L is given as 2 and the area of cross section is given directly, that is 1.25 into 10 to the power of minus 6 meter square. So when you solve this 10 raised to minus 6, you can take this value into the numerator. So you will get 1.6 into 2 divided by 1.25, and you can write 10 raised to minus 8 and 10 raised to 6 together. So when you solve 1.6 into 2, you will get 3.2. 3.2 divided by 1.25. This is 1.25. So 1.6 into 2 divided by 1.25, you will get the value 2.56. And 10 raised to minus 2 into 10 to the power of 6. So on simplification, this value will be 10 to the power of minus 2. Okay. So 2.56 into 10 to the power of minus 2, and the unit is ohm. Next one, calculate the area of cross section of a wire if its length is 1 meter. We need to calculate the area of cross section. If its length is 1 meter, so L is given 1 meter and A we have to calculate area of cross section. Its resistance is 230 ohm meter. So R equals 230. Ohm. This is symbol for ohm. And the resistivity of the material is, resistivity rho is equal to 1.84 into 10 to the power of minus 6 ohm meter. Okay. So calculate the area of cross section. We have the expression R is equal to rho into L by A. If you cross multiply, you will get A into R equals rho into L. Therefore, A equals rho into L divided by R. This is the expression for area of cross section. Now, you can apply the values in the equation. Rho is 1.84 into 10 to the power of minus 6 into length. The length is 1 meter divided by R. Resistance. Resistance is 23. This value is 23. 23 ohm. So divided by 23. So 1.84 divided by 23, which is equal to 0.08 into 10 to the power of minus 6 meter square. Or you can write, if you take these two decimals, 0.08, two decimal point, if you are moving into right hand side, this will become 8 into 10 to the power of minus 8 meter square. Then one more question we are going to solve. If a 6 ohm resistance wire is doubled up by folding, so you have a 6 ohm resistance wire. For example, consider this is your copper wire, okay, and its resistance is 6 ohm. R is equal to 6 ohm. And this wire is doubled by folding. So we are just folding this wire. Now, calculate the new resistance of the wire. So R is equal to 6 ohm. So before this L we are taking, length we are taking it as L. Now when you folding the wire, the length becomes L by 2. For example, if it is 4 in the previous time, 4 centimeter, now when you fold it, the length will become 2 centimeter. So L becomes L by 2. So this is a new length. New length after folding. It becomes L by 2. Now the area is changing. Now the new area becomes 2A. Now the area is increased already. So the new area will be 2A. Therefore, R is equal to rho into L by A. This is our normal equation. So when you substitute this one, rho is a constant value, and L here we have L by 2 and A is 2A. So your equation becomes rho into L. I am writing L by 2 and area is 2A. So 2 into 2A. So overall it will comes like rho L divided by 4A. If you are keeping the constant little away and make 1 by 4 near to the rho, you will get 1 by 4 into rho L divided by A, which means R is 1 by 4th times reducing if the length is L by 2. So the previous length is L and you have folded the length, okay, then it will become L by 2. Therefore the resistance becomes its 1 by 4 value. So the previous resistance value is 6 ohm. Now it is changed to 1 by 4th of the previous value. So it means 6 by 4. So 6 by 4 means 1.5 ohm. So when you fold a wire, its length is divided by 2. You need to divide the length by 2. So it becomes L by 2. So which means the resistance will become 1 by 4th of its original value. Original value was 6 ohm. When the wire of length L. Now the length is divided by 2, so that the resistance value becomes 1 by 4th of its original value. So 6 by 4, that is 1.5 ohm.